All right, excellent. I hope that will be coming up now. Right, so in terms of like what we are trying to do with our latest on-chain upgrade, we might have communicated this idea of resources on Ledger and why they are important for decentralized identity. And what that brings us to is maybe to first ask the question, why are resources needed in digital identity? So if you take a simple example, right now, when you issue digital credentials, you might have come across a term called schemas. This is very commonly used across a wide variety of decentralized identity projects, and they're often defined as what does this field mean? And if you think about it, these are naturally used in traditional identity documents. So if you think of a driver's license that you might have or a passport that you might have, you'll see that they have a certain structure to them. So for example, within the UK, within the US, in other parts of the world, you might find that a traditional sort of like plastic card or an identity document has some fields to it that are pretty consistent. So when you show it to somebody else, they know this means the first name, this means the last name, this correlates to their date of birth. And schemas in digital identity are just a machine-readable and digital way of representing the same thing, so that when you show some information to somebody else, they understand what that correlates to. But what you also see an example of is documents and schemas change all the time. So in this example, we've taken an example of like a license that was issued in 2012 and 2015, just 3 years apart. And within that time, it's quite likely or quite possible that the structure of the document itself might have changed. And so while the first thing that you see on the left-hand side might be valid for 10 years, the thing that you see on the right-hand side is also a driver's license from the same country, but it has a new structure, a new way of representing things that was previously not done. And that's quite important to understand within the digital identity context, because a lot of the existing systems quite often allow you to specify whatever, but don't allow you to understand how it has evolved over time. And so the problem this can create is if you go and show a credential to someone, perhaps a couple of years down the line, like you might do in real life, what you might find is that schema itself no longer refers to the same thing. So for example, a lot of digital identity projects right now use a community-led effort called schema.org, and they have a common definition for driver's license that might help a lot of people understand it. But if that changes over time, then it becomes harder for machines and computers or even people to understand what the difference in those things mean. And so what might happen is if you're only referencing what the latest version of something might be, or not helping people understand how these things evolve over time, you might find that if you're presenting a credential that was issued a couple of years ago, you find that, like, you know, the computer just sort of like, computer says, oh, that's, I think, a very British reference, but it allows you to say there are realistic challenges in the long-term sort of how digital credentials can be processed over time. And this also then brings me to the second point, which is if you have something that is at a web link, then what are the challenges that could cause? So a good example of this is back in 2021, but also other times besides that, Facebook went down for like a solid like 6-ish hours. And during the same time, any app that was using login with Facebook also almost instantly crashed. It was not even something that they had accounted for, that something as large as Facebook might not be available. So a lot of apps that had been designed to use the Facebook ad tracking pixel or the Facebook login with Facebook stopped working. And this has happened not just on this particularly large instance when all of their services went down, but it went to a huge range of cloud providers. So you can say, well, AWS is trustworthy, Azure is trustworthy, Google is trustworthy, and they own a lot of the cloud compute power around the world. But the consequence of that also is that there have been very well publicized and very well sort of documented system outages where AWS has gone down, Azure have gone down, sometimes for hours and sometimes for days on end. And so that's just to highlight that when you're trying to deal with things like identity systems, there's some real benefits that come out of like decentralizing and storing this in a fashion that makes it possible to access at any given point of time. And something also you might have come across while just browsing the internet. Sometimes you come across a link on a website and you click it and it just doesn't go through the right thing, or it's not found, or and that is called link rot. So that's another thing that we wanted to tackle and solve and account for. So the original example, we said it was schema.org/driver's license. And that, to be fair, is a really well and stable maintained sort of thing that has existed for quite a few years now. But it is not unrealistic to assume that there might be one particular day that comes and that content is not available anymore. And so the challenges that causes in digital identity is like, how long-lived are these things? And sometimes it could be because a company stops to exist. It might be because nobody maintains it anymore. And there's many different scenarios that lead to it. The graphs that you see was an analysis from New York Times. The red bar shows from a time range of 2009, I think, to 2019, so a period of 10 years, how many links that were just referred to on web pages had died. And you can see that it's a growing number that accumulates over time. And then finally, when you think of the space that is behind decentralized identity, you could always say, we could store these decentralized identifiers on a web, and in fact it exists. It's called DidWeb. The challenge is, what happens if the hosting provider gets hacked or goes down? There's similarly another method that says you can store it perhaps on GitHub. And that is also problematic, because what if GitHub decides you violated their terms of service and they suspend your account? So there are natural advantages to storing certain kinds of decentralized identifiers on a blockchain-based system like the cheqd network is, because it makes it immutable and it also makes it tamper-evident. And in case, for example, any one particular node goes down, is still highly available and highly redundant across a lot of different nodes that host this data. And so if you think about it, we've obviously spoken about schemas, and that's an obvious example where this is used. But just to broaden that out, and we started looking at how could we tackle these issues like link rot, making things tamper resistant, making things survive, like, sort of widespread system outages through just a single provider like AWS or Cloudflare or Azure and whatnot. And so we also then started to look at, am I back?
You're back, yep.
Am I back?
You're back.
All right, good, excellent. I might just turn my video off because I think it's, okay, I'll just go ahead and then look at it. So schemas is one obvious example that we took, and it is tackled across a lot of decentralized ID systems, but wanted to then look at, well, what else could this be applied to? So not just solve the existing capabilities that exist in a lot of decentralized ID networks, but go beyond that. And so examples we came up with is, you can take the example of visual representation of credentials. Right now, if you went to wallet.cheqd.io, you can connect your Cosmos wallet to a website, the wallet.cheqd.io website that we have. You can then authorize yourself against Discord and Twitter, and it will then give you a credential that says, you do own this particular handle on this service online. And typically that's just shown or designed to be kept in a computer readable format or machine readable format. But there are scenarios where you might want to have visual representation. So take the example of things that you might store in Apple Wallet or Google Wallet. And we took this example here, shows a mobile boarding pass. Now, there's obviously machine encoded information that says this is the person's name, this is the seat number, this is their airline ticket number, and so on. And that is what you scan and when you get on the plane. But there might be a visual representation that you want to have for branding reasons, or in this example, if you have gold status in BA, that's a gold background. If you have silver status in BA, you have a silver background. If you have no status, you have a white background. And this, for example, might be used in a scenario where they're not actually scanning your boarding pass, but there's just somebody at the airport who says, that's the queue, you need to go join. So there are enough scenarios where maybe just to make it a bit friendlier for people to understand what information is present within a credential, that you might want to have a resource that describes what this credential looks like. And so to give a different example outside of the Apple and the Google world, there's a standards format called the overlay capture architecture. It looks like a complex diagram, but the main point here is it came up when I had a discussion with some people who were working on decentralized identity in Canada, where they legally have to do government documents or credentials or government services in 2 languages, French and English. So how do you then, oh, okay, might just be lagging. Let me know if it is lagging, hopefully catches up. But what you might want to do is you want to account for things like that. Like in Asia, you might want to represent the same credential with in the local language. You might want to have things like this visual representation. You might want to be able to do a lot of like rich ways to enhance how people understand and read credentials. And that is another example of a resource that might be used within digital identity credentials. Has it caught up now, or is it still lagging?
Yeah, we're on the right side now.
Good. Then to extend that forwards, and I'll stop in a second, is the idea of revocation registries. So this is based around the concept of a credential was once issued to you and it is valid, but that doesn't necessarily mean it is currently valid after a period of time. A good example of this is, so I used to have a citizenship of a different country, and I have a passport with a validity, or the expiry date says that it expires in 2028, but I don't have the citizenship of that country anymore. It is a valid document. It is an official government-issued document. So if I wanted to go use it at an airport, though, the problem is they'll be able to perhaps run checks or understand that this is not something as citizenship that I hold anymore. It is a valid document, but it's not currently valid. And so those are also things which are currently handled by some ledgers, like Hyperledger Indy has revocation lists. There's also status list that is W3C standard, which is the World Wide Web Consortium, and that could also benefit from doing this. You might want to have governance policies or trust frameworks or documentation that you want to mention. So, for example, there's how do you figure out who is trustworthy in terms of issuing credentials? And what you might have is either a community-led or a government-led like scenario, which says these are the trustworthy issuers. Or in our case, for example, when we're running a decentralized identity network, we have a governance framework, and the trust over IP specification, for example, says that people should make their governance framework available through a DID, but the actual implementation and can be achieved is not something that people have really gotten into. So that also is a fantastic example. I'll end on is a lot of you might have used the cheqd blockchain explorer, and if you look at the logos that come up that says this is the validator, those logos are right now pulled from a website that is owned by Zoom, the video conferencing service, called keybase.io. And so what you do is you go and establish a profile there, and you upload your logo on there. And then you specify it on the Cosmos blockchain network, on the cheqd network. That is my claimed Keybase profile. And so what we start sort of like getting a picture of is it's not just other technical things that resources on Ledger are useful for, but these are all things that create like good quality of life improvements, and that will make this new world of like Web3 and decentralization a lot more friendlier for people to use in real life. I'll pause there for a second for any sort of questions or people have. We've obviously described the problem. We've described the context it could be used in. The next bit, I'll go into how to solve this. If there are questions, but please do feel free to like type it into the chat window on the right-hand side. Like if you expand it, very happy to stop and answer any questions as they come along. So how resolving these problems with the latest on-chain upgrade that we did on Tuesday? So we started considering these issues and these problems, and obviously this might go into a bit of a technical discussion. I think there are quite a few of our partners on our call who understand these concepts, but feel free to stop me and ask me if there's an aspect of this that doesn't make sense. So the basic concept is that you have DIDs, or decentralized identifiers, and they have contents called DID documents or DID docs that are stored on chain. And so the first process that you start is you create a DID on cheqd, and we have a lot of like documentation and on our product site, on our learn site, on our technical doc site. And once you have created this DID doc, what that specifies is a couple of things like what are the public keys, or what are the public signatures of this, the person or the organization that created this DID doc. And it also allows people to, for example, have multiple keys or multiple signatures. This could be a scenario where multiple people control this. So let's assume that you want to go and publish a schema of what a passport looks like, and you want to publish that using our the current like release that we did on Ledger. So compared to the old world, instead of publishing it on a website like cheqd.io/passport, what you do is you go and first create a DID doc, and then once you have done that, that list of keys that you have published becomes the controllers for who can upload a resource on chain. And so what you can then go and do is you can create a resource, and we sort of like look at this as like there can be many different resources within a resource collection. And what that allows us to do is to do two things. It first allows us to say there could perhaps be multiple resources. You could say, this is my logo in a JPEG format. This is my logo in a PNG format. Or you can also say, this is my passport schema as of 2012. And then you can go and publish a new version that says, this is what passports look like in 2025. And that exactly is quite powerful, because what we want to achieve here is, like, if you see the bit in the purple, the collection or the grouping that like ties back to a DID document that's used for control, and the bit in purple is a unique link to the version of this particular version of a passport schema that might have been published in 2012. And like what's also sort of quite interesting here is if you look at this arrow at the bottom, then you can also link it to previous versions and future versions. And you can sort of go back and forward in history and see what did it used to look like, a bit like how you might see on GitHub, or you might see in document history on Google Docs. And so the final thing, or this step, is we wanted to make it discoverable through this thing that has just been accepted as a recommended standard by the World Wide Web Consortium just this week, and it's been finalized. What you can go and do is you can go and mention this in a section within the document that is called the service section. Now, we went with this option because it is designed to be extensible. And so if a software application doesn't understand what this means, it just sort of silently ignores it. And if it does understand what it means, then it can read this and say, okay, so that looks like a passport. A CL schema is something that has been created within the Hyperledger Indy world, so I know what formats of schema it is. And then the thing that says service endpoint, that is the link through which you can go and access this particular, what are the contents of this. So in this example, we've given passport schema, but that could, for example, very easily be a logo as well. And so how do you reference this? So on our ledger, you can do it in two styles. When we originally launched our network back in November last year, for ease of use and for compatibility, and we've always had an eye on interoperability and compatibility, we adopted the same style that was used by Hyperledger Indy, and that's what you see at the bottom. You'll see that it says Indy style identifier. But we wanted to sort of expand this and to make it a bit more easier to generate and easier to understand, because this particular unique identifier, the Indy style identifier, is generated from one specific public key or from one specific key that you use to sign these documents. The problem with that is if you ever change the key in the future, the two are suddenly out of sync. And so what we have done as part of our network upgrade as well is to support a kind of identifier called a UUID, which is a universally unique identifier. And it's used in a lot of places. It's used in a lot of scenarios where you need to have a unique reference to something. So a lot of the social media networks, for example, might use something along these lines to say that is a unique version of this particular post. And what that achieves is the bit at the green at the end then is the specific file or the specific schema. And when you mention this within a issuer's doc, what you can do is you can also extend it. So for example, if somebody has already created a schema for passports and you want to reference it, before you start issuing somebody digital credentials, you might then create a separate DID doc, which is called an issuer DID doc, and say, actually, I'm going to use this schema that was created by somebody else. It could have been created by yourself and just have different public keys, but then that allows you to go fetch the resource. And what's quite powerful about that is that it allows a wide range of reuse, where just like people right now use schema.org/driver's license, you can reference other widely used schemas that have been created by somebody else and still be able to reference it. And how is this used in a digital credential, like a verifiable credential? Well, this is a bit of a truncated section. It doesn't actually have my passport details on there, but you'll see at the bottom, it references something called a credential schema, and then you'll see that it refers to what is called the resource collection. And the bit at the end in purple says that that is the specific version of that file at that point in time that was valid. And so what's quite useful is, like, you can then go and discover, are there new versions, are there older versions, and this can be achieved in many ways. And that's just a URL that you can load in your browser. You can perhaps go ask your software application to go and fetch. And so this is an example of like how this can be extended like even further to say, I want to find out what did passports look like on the 1st of July 2022, or I want to look at what did something called passport within this collection look like back in 2015 perhaps. And because this is all tied together, because these are inherently referenceable, you can say, this is what it used to look like back at that particular point in time. And so what it also allows is something that just does not exist in a lot of decentralized identity right now, which is to see how has some kind of information description evolved over time. And so just to summarize, you have a DID that is used to write a DID doc. You can then publish any number of like resources or files underneath it. One caveat is that on cheqd network, our maximum block size is 200 kilobytes. So if it's larger than 200 kilobytes, you probably should be publishing it somewhere else anyway, because, for example, if you had a video file that, or just a PDF that was 20 megabytes in size, that doesn't fit within an entire block, and to start increasing block size to massive levels to accommodate that is probably a bad idea, and it's not very efficient anyway. But the technique that we've described can also be used for things that you perhaps don't store on a blockchain because maybe they are heavy files that could be stored in other kind of decentralized storage, like IPFS, for example. And then you can go and fetch that at any point in time. So this is an example, like we got accepted into this project from the Decentralized Identity Foundation earlier. A lot of the people on the call are developers from our team. So you'll see the cheqd like showing up on that logo. You can see this if you go to dev.uniresolver.io. And one example of what I described is, yes, you can have them on Ledger. Yes, there are a lot of benefits to doing that. But there might just be some examples where you don't want to. This particular one is a DID that we created, the first one on our network, in fact. And you'll see that it has a link that goes to an image. And this particular image is 6 megabytes in size, and it's what we call like the data wars poster that we have. So if you click the link that you have on screen when we send the PDF out, you'll be able to see that as an example of something that might have been too large to store on a blockchain, but it could still use the same techniques that we presented to describe how they should be accessed and used. And so to summarize, we wanted to handle a lot of these different scenarios, make them referenceable and immutable, give a way of storing them on the cheqd ledger, but also off ledger if you so desire. It should be version controlled so that you can find older and newer versions. They can be indexed so that you can search through them, a bit like how search engines might work. You might be able to resolve to them directly, or you might be able to update them in the future. You might want to mark something as, this is not a version that's used anymore. So you can mark something as deprecated or superseded by new versions. We also really wanted to make it possible to do this using the existing W3C standards on decentralized identity, which from what we've seen so far, not a lot of other projects are doing. And for developers, we also want them to be able to understand when they receive files, what is the specific file type they're receiving. So for example, they need to understand that this is an image, this is a video. So so that when you fetch the file, you understand the file sort of like type. I'll pause there for a second and stop for any questions. Anything in the chat as well, by the way? I see like, okay, hang on, just a lag, okay. Thoughts, comments, yes?
All being very well received, obviously.
All right, okay. If no, go on. Sorry, your audio is quite faint, by the way.
Oh, right. Well, yeah, probably my computer phone. So you said resources that are larger than 244 kilobytes are stored off ledger, but pointed to by like some sort of, well, it did.
200 kilobytes.
Yeah, I work a lot in the ceramic world, so I guess you kind of have a CID. You can kind of point to it if it's like stored on IPFS in a way. You get a DID out of that.
Sorry. Is a governance parameter, by the way. So the block size can be changed through an on-chain governance vote. So at the point we launched, it obviously just said it was storing not very large payloads. So I think it's pretty open to discussion on whether you want to store it perhaps or increase it. And I think that can be done through an on-chain increase of what the block size is, and that would accommodate larger like things to be stored. But there is a trade-off there of going and increasing the storage that must be provisioned by every node operator as well. So I think that's probably a balance. And I think if you think of examples like a video file where you might want to use other techniques to accelerate the video file, or to say, if the download speed is bad, download it in 480p. If the download speed is good, go up to 720p and so on, that you probably want to do anyway for like larger than a certain sort of like size. So generally the idea that we're talking about is to say they should be describable and discoverable through DIDs, and some of them have a lot of benefits of being stored on Ledger. And there might be others who, because of the use case or the file type, might choose to not do that.
Thank you.
Did that answer your question?
I mean, it's very sort of. At least it kind of got you to talk about something that I didn't think about. So.
Oh, okay. I'm glad. Huge ceramic fan, by the way. Say hi to Lauren. So to move on there, we also then take this to the concept of anon creds. I don't know how many people on the call know about this standard, but it is a credential format that is used in Hyperledger Indy, which is one of the more OG, so to speak, decentralized identity blockchains, and it comes with a whole host of like different protocols like Hyperledger Aries. And so anon creds is a way of like describing, it's a particular credential format, but they currently do store schemas on Ledger. They do store credential definitions, as they call it, on Ledger, but it's a pretty custom to them of describing it and fitting it and writing it, and therefore it naturally limits the amount of interoperability that you get out of it. And also, theoretically, the way this was supposed to be designed is that Hyperledger Aries, which is the layer through which a lot of this communication, or how apps are supposed to talk to the ledger, was supposed to be ledger agnostic, but in reality, it really wasn't. So when we started looking at this space, we wanted to support multiple kinds of ledger. You can already, ledgers and credential formats. So you could already use JSON credentials, as they're called, on our network. But we also wanted to know and recognize that a lot of the world still uses Hyperledger Indy. So how can we support the credential format they currently use? And so what we worked on is a mechanism through which the same things or the same resources that are required by Hyperledger Aries and Hyperledger Indy could be replicated across onto a ledger. So if you have a schema, and in Hyperledger Indy, this is called a CL schema, you can store a CL schema on Ledger. We don't really police or regulate what kind of resources can be published. We wanted to keep the flexibility open for developers to be able to do that. And you can therefore also go and publish credential definitions, which is the second piece that they require. One of the reasons why anon creds is still actually relatively popular is because they support a form of like zero knowledge proofs, which a lot of people have heard in the context of self-sovereign identity. And it's one of the more widely adopted like standards that can actually do zero knowledge proofs, because not everything in SSI can. And so the construction of it works pretty similar to the previous things that we discussed. You create a schema doc, you go and define the schemas to be stored within a collection, and then the issuer might say, I'm going to use this particular schema and go and write a credential definition. A credential definition, to give a very simple explanation, is to say, here are the schemas or schema that I'm going to use, and this is the type of like key that I will sign with when I issue a credential, and this is where the revocation registry is. This is the kind of credential that can be revoked or cannot be revoked, and so on. And so because we aren't really restricting what kind of like resources can be stored on Ledger, this could be defined as a cred def resource on our Ledger as well. And in terms of a diagram, it sort of like starts looking a bit like this, which is a schema could be stored, and it has a definition, it can evolve over time, and so on. It could be on cheqd, it could be on IPFS, and then where you have the issuers did doc that like sort of combines it together and makes it happen. The benefit of this is really to say, when you think of the most popular sort of or most widely adopted sort of like digital identity sort of projects that have happened so far, and we've worked on quite a few, like the Known Traveler Digital Identity Initiative, like the National Health Insurance project in the UK for identity for doctors, and so on. A lot of these use anon creds. The government of British Columbia and Canada also uses this for a lot of credentials that they issue within that region. So it's about like not saying you have to use anon creds, but to say, how can we make this much more interoperable and work across different credential types and ledger types? And what we've just released on our network this week brings that a step closer to reality to make it happen. I'll pause there again for a second. Like the last bit is a demo or not. I don't know, actually. I haven't been looking at my Slack messages, Ross. I can obviously do like a demo on screen with the wallet tutorial, but happy to stop for any questions, thoughts, and ideas.
Yeah, we'll go through the architecture diagrams and talk through our kind of choices around Veramo, and that'd be great.
Sure. So obviously what we're doing on Ledger is fantastic, but if you cannot consume it within an application, if you can't use it in your browser plugins, if you can't use it in your web apps, if you can't use it in your desktop applications, it's not very useful. So we've been tackling that problem and how to make it as easy as possible as well. And so what we have been working on for the past few months and have been code releases, but this has sort of reached a level of maturity now, is we worked with an existing SDK which came out of consensus, a consensus project called Veramo. And what Veramo allows you to do is that there's a whole bunch of things that have already been designed by Veramo, by the Decentralized Identity Foundation, that allow people to issue credentials on Ethereum, to issue credentials on DidWeb, and other sort of like supported methods that they have. So we didn't want to necessarily go reinventing the wheel, because cheqd is not trying to be in the business of issuing credentials or necessarily building apps or web experiences. We really see a future where these SDKs can be consumed and used by a whole range of applications. And so if you see on screen, like the yellow boxes are things that exist. This is a set of developer tools for decentralized identity that a lot of people already know and use and love. And what we built for that is the bits in green then comprise the unique bits. So how do you read something from the cheqd network, and how do you perhaps write things to the cheqd network, and that sort of like breaks down into components where there's a lot of functionality that comes out of the box from Cosmos, but we have implemented this DID module and this resources module, for example, and those are unique. And so we designed that to be available as sort of like a low-level package. And to give an idea on how that could be extended, we're not necessarily saying that Veramo is the only SDK to use it in, but to suggest and show a world where the same low-level package could also then be extended and used in something like Hyperledger Aries that already exists and is used by indie networks. It could be used by other SDKs like Evanim, which has something called VDR tools, and so on. So this is currently written as a Node.js package, which allows a lot of reuse, and it allows people to integrate it within their own applications. We'll probably have enough time for a demo, in fact, to run through something that we built using this sort of like structure for our own experience. But one thing that we really, really wanted to focus on and make available is a lot of the Hyperledger Aries libraries right now, you cannot really use them in a simple fashion within web apps. Because of certain technical limitations, you always have to use them within mobile apps or desktop apps or something that is targeted for a specific computer or like operating system or platform. And the disadvantage of that, of course, is that it leaves out a whole range of like very rich applications that could be defined and created as web apps. But also it forces a particular model within this space right now where many Hyperledger sort of indie-based applications often use something like a cloud backend. And so, which ultimately feels a bit like it's counter to some of the objectives of decentralization. If you have to always rely on a specific company's cloud backend or cloud provider. So we really wanted to make it possible so that you can use it with your normal Kepler wallet, or if you're coming from an Ethereum world, then the equivalent is sort of like MetaMask, and be able to do this and use this with web applications. Which brings me to a demo that I can quickly show, and a lot of people can go and see this themselves. But in order to do that, I just need to reset my screen share and bring that up, which would be, there you go. Has the screen come up again?
Yep, it's loading now. Just about.
Excellent. All right. Hopefully not too much lag there. So if you go to wallet.cheqd, you'll find a tab called Identity. And what we've designed here is a mechanism similar to what a lot of password managers use, which is you will have a web wallet that is only sort of stored and encrypted within your browser. And there is a backup in the same way that you might back up your phone to iCloud or Google Drive in an encrypted format. They don't have the keys, they can't open it, they can't see how it works, especially for things like WhatsApp. Or if you take the example of password managers like LastPass or OnePassword, what they do is you're able to store your usernames and passwords within them. So for example, I have that right here, and that has my usernames and passwords and bank account details and all of that stored. But they don't actually know the details. Like what happens is I log onto my account, it downloads an encrypted copy, and then it decrypts it, but only on my client side. So we wanted to show, we took this challenge on specifically because we wanted to show the fact that like it could be working in an entirely like sort of transferable fashion like this. And so to log on to it, I sign in or I authenticate sort of using my Kepler wallet, which is my cheqd account that I have on the ledger. And if I prove that, then similar to a password manager, it asks you to enter a passphrase to lock or unlock the credentials. And what I can then do, and what we've done in this experience, is to say you can connect it to any sort of social media account like Twitter. And what it does is it goes and fetches and checks, was I actually able to authenticate myself against a Twitter account? In this case, I did. And then I can click Get, and that gives me a verifiable credential that has been acquired. Now, we designed this wallet.cheqd.io experience not as necessarily a consumer service that we ourselves are developing and we want people to use, but we use this as a demonstration of seeing everything that you've seen so far and the SDKs that we've been building to say, can we perhaps extend a normal web wallet that we already had for doing Cosmos-specific functions or check network-specific functions like transferring tokens, like voting on governance, like doing the delegations on our network, and to extend that and provide the capability for people to hold credentials. And what we want to be able to show through this is to, like, as we go on releasing these new features on chain, be able to demonstrate and give a bit of a reference application for developers to be able to see what they can do with our network and how they might be able to build it into their own applications. Oh, sorry. I forgot to show this. So this is the credential that came back. And if you look at it, this is the computer readable code. It says it was issued by this particular issuer. In this case, it says this is the public key involved. It defines the type of credential that came back. It says this was the date on which it was issued. And it also then describes what was the type of profile. So it's of type profile page, it's Twitter, that's the name of the handle, and when was it sort of last reviewed. And then it provides this as something called a JSON web token. If you haven't come across this, it's a way of encoding information, and this is the bit that makes it a cryptographically verifiable credential. So if you go to an online decoder, I'm going to be able to show this a bit more easily to say, if I decrypt this, you'll see that it sort of breaks it down into multiple parts. The bit in red is just a header for computers to understand what this is. This is the actual body that you just saw on the credential, and you'll see it matches the things that you were seeing. And right at the end, you'll see that there's a signature that's in light blue, and that's how you can see if something's been tampered or not. If any of these parts get modified, like it invalidates like the others. And to come back to what we originally said, this is the level of formatting that you often see in the digital identity world right now, which is you read that machine readable code, you dump it into a table, but it's not particularly aesthetically pleasing, and it's not how a lot of existing credentials or things that you might, for example, store in Apple Wallet, Google Wallet, and so on, they are displayed. So what we did with the resources on Ledger had been able to say, this is the visual display, this is the logo, these are the ways in which you can actually visually represent this. I think it would make it a lot more user-friendly as well. So that's a concrete example of like something that's working on our network with the SDKs, but right now, because it doesn't use the resources functionality, you can almost imagine how this could be improved and be made easier to understand and use. Cool. I stopped screen sharing. You didn't lose me. I know that we have about like 8 minutes on the clock left. So I'm very happy to sort of take any questions, ideas, thoughts, and yeah, over to people on the call.
I guess I can ask a question, Ankur. So I guess it'd be interesting to understand a bit more about how we're planning to expand and help support our partners to expand on the Veramo architecture for other SDKs. I guess perhaps just like a kind of a call to attention around what we're kind of planning there.
Yeah, no, that's a very good question. So we recognize a lot of the ideas that we are presenting over here are quite new, and a lot of this works through industry bodies and groups and then evolves. So we are talking to a lot of the authors of the specifications or working groups within these bodies. But something that we right now have is that the Veramo SDK is fairly solid right now. If you want to read from the ledger, create credentials, verify credentials, verify showing like presentations of them to someone. In the process, we went and like made like a couple of open source contributions upstream to a lot of the things that Decentralized Identity Foundation is doing as well, to allow new kinds of signature formats. And at the moment, we are going through a process that makes it easy to create DIDs using the Veramo SDK as well. And the idea then there is we'll be able to take the low-level SDK library and make it available to any other application that is capable of consuming languages like Node.js packages or TypeScript packages, or be able to consume things like WebAssembly. So as long as you can achieve those things, and these are relatively common across the industry, it allows people to integrate it into new kinds of SDKs. So for example, the Hyperledger Aries SDK. But if you already use Veramo, for example, which is built, then you can use the Veramo SDK that's already published through Node.js. You can use it to build web apps. You can integrate it into your mobile applications. You can integrate it into desktop applications. And there's a whole range of like functionality that you can build into existing applications as well.
Nice. Cool. Thanks. Yeah. So if anyone is interested in kind of wants to be part of supporting, if they just reach out to myself or Ankur as well, we'll yeah, bring you into that conversation.
Brent did ask a question on the overlays capture architecture. That's, I actually haven't looked at that link and what that might be, but I just pasted a link into chat. It's from the Human Colossus Network, and if you go into that, you'll be able to click on the top right for the spec as well and see this. It's essentially a very rich way of describing the semantic, the input, like the ways you can transform it, and especially for internationalization, it tells you this is the equivalent of like this particular field in like French or in Mandarin. So that was brought up as an example of like how resources on Ledger, in fact, we didn't come up with this idea. It was Stephen Curran from the Anon Press Working Group who came up with it. And yes, exactly, that one. Yep. It was actually prompted by vaccine records and vaccine test results, because a lot of governments started issuing them and making them available over the past 2 years of the pandemic, of course. But in their case, they had a legal requirement to do it in multiple languages, but a lot of countries have had to do that. So yes, that's a good example of something that could be stored on Ledger, for example. Originally, we were just planning on doing or allowing a couple of types of resources, but after that conversation, we sort of really pivoted and said, actually, people will come up with great ideas like this, and if we are trying to manually approve or gate which kinds of resources can be published on Ledger, that becomes extremely complex and challenging to support over time. So working with the dev team, we sort of like worked and figured out a way to say, make it possible for anything, so that these ideas, people can go and build these ideas on our network very easily.
So that's
Cool.
Cool.
Brent, go on.
Yeah, so that's something you're working on. That's something interesting. I guess I met Burak and the Human Colossus Foundation, Paul Knowles, at it was a virtual IIW. I think it was last year sometime. So, but I thought it was kind of cool because not everybody's getting creative about what the semantics are, but also logically how everything can map. But I was thinking like deeper. I think JSON Web Tokens don't actually allow for semantics. Well, it's just a JSON blob. It's not really like JSON LD, so there's like no context tag within it. But I think, correct me if I'm wrong, you can still partition and you can try to have some interrupt amongst the JSON at least. Maybe not like in terms of meaning, but
yeah. Completely agree with you. So I think like JSON LD with BBS Plus, obviously, pretty rapidly evolving, and in some senses a very mature standard, and in some senses still being worked upon. But again, we don't really have a particularly strong opinion about it. I think if people want to have 50 different kinds of ketchup available in supermarkets, I think that should be possible. And if they want 50 different credential formats, that should be possible. So in terms of like how we go and support things on our network, we're very open to supporting multiple formats. I think BBS Plus is definitely one of those that we're looking at. Yes, so we're just doing one step at a time. I think what you also just prompted me to think about, and what I forgot to mention, is the OCA architecture is quite nice, and it is great for and has arisen out of the VC industry. But just to take a simple example, you might want to have a verifiable credential as a QR code and be able to export it to Apple Wallet and Google Wallet. And you might want to say, these are my Apple Wallet and Google Wallet sort of definition files. So we definitely see a future where, for example, if you're consuming something within an SSI wallet or decentralized identity wallet, it might use something like OCA. But if you then, if you want to offer compatibility and people add it to things like Apple Wallet, Google Wallet, then you might want to say, here's the same thing, but in a different format. So I think that's also quite powerful. Brent, did that answer that? And I know we are at time, so a lot of people might need to drop.
Yeah, I'll just say thanks, and that was kind of cool. Yeah, Verex work and the schema overlays is something I'd like to dive in more deeply, but I just I never really could seem to get to it because I like have other tasks that I'm trying to get done first. But it's kind of cool. Yeah.
Honestly, it could be stored in ceramic as well. Like if you yeah.
Yeah, I mean the interesting thing is ceramic and well, there's like 3 or 4 companies that all kind of drew off of the Uport work, so it's basically all using DidJot basically, and what was I say? Yeah, so there's some commonality there, but yeah, I don't know about I guess enough about your system about like how it works, because ceramic kind of trying to be an open data network, and how are you different than ceramic in a way? I know ceramic doesn't necessarily want a lot of things on chain either. You know, they're going to get they have their own standards. Oh, okay, but I think you was sort of following your CEO. I forget what his name was, but he started talking about the Chain Agnostic Standards Alliance, and I know there's some collaboration between some ceramic folks on that, and you're kind of in there too, because well, yeah, that gets beyond the DidJot and stuff like that, just kind of because they're looking at right, because like ceramic's kind of this permissionless. Well, yeah, I guess it's permissionless. It's kind of this open data network, but this is the
ours is permissionless as well, to be honest.
Stuff. I'm rambling.
Ours is
sorry.
Ours is permissionless as well, to be honest. I think the real sort of, it's not a private permission network. It's not like Hyperledger Indy. I think the real answer is sometimes it just gets too religious on what blockchain is better than other blockchain or decentralized system. And I think that's kind of missing the point. So for example, if I want to reuse a schema that was published on Ceramic, but the issue date is on cheqd, that's fine. Or the other way around. And it's the same way that like I might choose to host on Azure, you might choose to host on AWS, but our web apps can still talk to each other. And I think that is the level to perhaps think at, which is to say, we are generally quite like, you know, I don't say that there's this problem that needs to be resolved. Not every single feature or decision choice is going to be accepted by everyone, and that's fine, honestly. And that's the reason why you have a lot of choice in a free market economy on you know what products you use, and that's completely okay.
So you said that like I could have something that follows a ceramic data model and the schema. They have their own way of doing it, I think, but like basically a credential that's kind of stored, persisted within the ceramic network, be used with your stuff in a way, or?
In applications, yeah. So that would be, if you look at the universal resolver, which right now supports, I think, like close to 40, 30 different DID methods. If you make these files discoverable, and find a way to describe them using the DID URL and the DID spec, then it doesn't really matter where it's published. As long as you have something like the universal resolver, you can always go and fetch them. So, for example, if something was stored on Ceramic, and by the way, like, you know, the fact that like they're completely different blockchains also doesn't technically matter over here, because right now when you reference things on a web endpoint, that's also completely fine, right? So the main idea, or the main point being, if such a technique is adopted by like the DID industry, as long as it's common ways, then it makes it easy for everyone's applications to fetch things from each other's applications. A bit like how just normal URLs work. Yeah, that one, dev.resolver.io.
Okay. All right. I'll have to look into that a little bit more.
Cool.
I guess I'm happy I came on this call just and see what you're doing, and talked about schema overlays and thought, oh, this is cool. I'll hop on. But, yeah.
Excellent. I'm conscious that we sort of overrun a bit on time. Feel free to reach out to us, of course, and Brent, please do if you want to have a chat. Ross, we'll send out the recordings, we'll put them up somewhere and send out the slides. But yeah, no, sorry, take it away, and maybe you can close it off.
Yeah, no, that's it really. Thanks, Ankur, for presenting, and yeah, we'll speak to you all again soon. Keep in touch. We'll be kind of trying to run another one of these webinars probably towards the end of August, perhaps, as we start to build out our next stage, which is replication registry, which will ultimately lead to the payment rails which we're building. So yeah, we'll obviously keep in touch, and yeah, just let us know if there's any questions you have. Thanks, everyone. Drop off here.
Thank you, guys.
Cheers. Bye-bye.
Cheers. Bye-bye.
Thank you. Bye.